1. Identify the intervals of increase and decrease for each function. We have the graph of, or we have the equation x squared plus 6x, and as you can see, they already graphed it for us, so we don't have to graph it on Desmos. It's already there. So if we want the intervals of increase, let's do increase first. So increase, when you're reading it from left to right, you're going to start at the vertex, and then you're going to go upwards here. Oh, all of this part, this is all increasing. I think it would be better if I just highlighted it. This is all the increasing portion. So when we're labeling it, what x value is this? Let's take a look. Okay, what x value is between -2 and -4? It's going to be -3. And we want everything to the right of -3. So you want x to be greater than -3. All right, so it's everything to the right. That means x is greater than -3. So we're going to start at the vertex, which is the x value of -3. Remember, we are talking about the domain, so we're only talking about x values. I don't want anybody to say -9. We're not talking about that. We are talking about the x values. Okay, then let's talk about the decrease. Let's use a different color to highlight. The decrease is when you read it from left to right, you're going down, 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 and it stops right there at our vertex. So that's going to be x is less than -3 because it's everything to the left of -3. So it's just x is less than -3 to indicate that we want everything less than to the left of -3. Once again, it should be the same number. If you had -3 as this number, it should be -3 here as well. It's the same number because it stops and ends at that exact same x value. Okay, so you guys are going to do number 2 on your own, but we're going to do the number 3 together. Same idea. I'm going to write our answers here. Increase and decrease. Okay, so let's do our increase first. Our increase is when you read it from left to right, it's going upwards. So that would be this section.
Miss Jade?
Yes?
Did we write anything else for number 1 on page 33, 133?
No, just that?
Oh, hold on. I didn't get the highlights on the thing.
Okay. All right. Let's
The
do
highlighting. Okay.
this one. Okay, so the increasing portion is that purple or gray or whatever color you see on your screen. So it's the portion where when you're reading it left to right, it goes upwards. And then where does it end? Okay, so remember you're reading it off the x-axis. So this is the number 1. We are reading it off the x-axis. So it's everything left of 1. So this is x is less than 1. Left means less than. So x is less than 1. Remember, once again, I don't want you to read it off the y-axis and say 9. We are not reading the y-axis numbers. We are reading everything from the x-axis. So we are taking the 1 and not the 9. Okay, so that was the increasing portion. Let's do the decreasing portion. So decreasing is going to start right here and go all the way down. As you go left to right, it should go downwards. So that's how you read your decreasing. And this is everything to the right of 1. So it should be x is greater than 1. Remember, it's the same number. So if you got 1 earlier, you're going to keep it as 1. So earlier, increasing was x is less than 1. Now for the decreasing section, it's x is greater than 1. So it's the same number here. All right, I'm going to pause it. Any questions or, any questions or anything, please let me know. And just to reiterate, one of the questions that was asked was, it's lined up from the vertex? Yes, it is lined up from the vertex, and you're going to take the x value of the vertex. Okay, let's go to number 5. Cool. Okay, so let's talk about increase first. Oh, and I guess I'll just write the word decrease as well. Okay, so for the increase, I do that one in purple. Increase means when you're going from left to right, you're going upwards. So that's that section. The increase is that section that's right there in purple or gray or whatever you see. And then here's our vertex, which it lines up with. We're not going to read the y value. We have to go up towards the x-axis to read the x value, which is 0. Okay, so in this case, we want everything to the left of 0. So this one's going to be x is less than 0. Remember, we're taking the x value, not the y value, the x value. So this is not -9, this is 0, because you go up and you read it off of the x-axis. And since it's all the stuff to the left of 0, then you want x is less than 0.
Could you scroll a little down? Well, at least I can't see. Like
Oh, okay, sorry. Like that?
Yeah, that's
Okay.
good.
All right, and then for the decreasing, it's everything to the right of 0. So it's like when you read it from left to right, your graph is going downwards. So that is your decreasing portion. And like we just said, it's everything to the right of 0. So if it's to the right, that means x is greater than 0. Remember that you want to have the same number here as you do here. So it's 0 in both cases. Increasing was to the left of 0, so it's x is less than 0. Decreasing was to the right of 0, so it's x is greater than 0. Okay, I'm going to pause the video here to see if you guys have any questions and to give you guys time to write. All right, so that was it for that section. Let's scroll down, and now we're on part B. It says, determine the x-intercepts of each quadratic function in factored form. So as you can see, all of these, 1, 2, 3, 4, 5, 6, they're all given in factored form, and we want to find the x-intercepts. So I want to show you on our notes. I know we already went over the notes, but I want to show you where to find that in our notes boxes so that later on, when you're doing it on your own, you'll remember to look at the notes because it's in the notes. Okay, so factored form is box number 10, and the x-intercepts will be given to us right here. So to get those x-intercepts, you would write r1, 0, r2, 0, and where do we get those? It's literally the number right here. Okay, x minus r1, x minus r2. So it's whatever x is subtracting in each of the parentheses. In each of those factors, it's whatever x is subtracting. And so notice that it's subtracting, which means we want to take the opposite sign of what's given to us in the example problem. So I'm going to show you what I mean by that. Let's go back to skills practice and let it load. Okay, so for number 1, if it says parentheses x minus 2, x minus 8, our x-intercepts would be positive 2, 0, and positive 8, 0. So literally just take this number, then take the 2. It's a minus 2, so you make it a positive 2. This one is a minus 8, so you make it a positive 8. And of course, these are points. Your x-intercepts are points, so you make them in coordinate form. So 2, 0, 8, 0. All right, so those are your x-intercepts. I'm going to pause the video, give you guys a chance to ask questions or write it down. Let's do number 3 now. Remember, I'm doing the odd ones, you're doing the even ones. So number 3 says f of x is equal to 3 times x plus 4 times x minus 2. We are going to ignore, that 3 in the front because that's our a value. That's not going to give us our x-intercepts. What does give us our x-intercepts are the numbers that are next to the x inside the parentheses. So if we have x plus 4, that's going to give us negative 4, 0. And if it says x minus 2, that's going to give us positive 2, 0. And how do we get the negative 4? We got it from the plus 4 over here. How do we get the positive 2? We got it from the minus 2 over here. So remember, you just switch the signs and put it in coordinate form. I'm going to pause the video, see if you guys have any questions. All right, sounds like there are no questions. So let's do the last one. Remember, we ignore the coefficient. We ignore the 0.5. And I do see a question in the chat, but hopefully that will be answered once I show you this problem. So Over here, if it says x plus 15, you don't want to write positive 15. You want to do the opposite symbol of whatever appears. So if it says plus 15, then you make this a negative 15. If it says x plus 5, then you make it a negative 5. So you just flip the symbol of whatever you have in the equation. So once again, the negative 15 came because we have a plus 15 over here. And then the negative 5 came because we have a plus 5 over here. Versus, for example, in number 1, if it says x minus 2, right here, x minus 2, then you have a positive 2. If it says x minus 8, then you have a positive 8. So you just want to do the opposite of whatever you get in your equation. If we have a plus 5, then we have a negative 5. All right. Now I'm going to pause the video, see if you guys have any other questions. All right, so that's it for that section. That's how we get our x-intercepts from the factored form. Now we are on to determining the axis of symmetry for each parabola. So we want the line that divides it in the middle. So number 1 says the x-intercepts of the parabola are 3, 0, and 9, 0. So I'm just going to kind of sketch it out really fast. You don't have to sketch it out. I just want to show you. If we have 3, 0, and 9, 0, I'm not even going to label the numbers. 3, 0, and 9, 0, and let's just pretend it's facing upwards, okay? If this was our parabola and you want the axis of symmetry, which I'm going to do in, I guess, purple, that's going to be the line right in between our two x-intercepts. It's literally halfway between, okay? Between the 3, 0 and the 9, 0 x-intercepts. It's just halfway in between. I also want to show you guys in the notes, so just let it load. Your axis of symmetry is going to be, you're going to take those two r values, your two x-intercepts, and you're going to divide it by 2. So literally just finding the halfway point. So that means our equation for our purple line is x equals 3 plus 9 divided by 2. Literally just add it together and divide it by 2 so that you can get the halfway point between it. So 3 plus 9 is 12. I don't know why that took me a while. So it's 12 divided by 2 is equal to 6. So our equation of our axis of symmetry, I don't want you to just say 6 because this is a line. This has to have an equation. It's x equals 6. This is your equation. X equals 6 is our axis of symmetry. And it's halfway between the two x-intercepts. It's halfway between our two black dots. It's the vertical line there. All right, pausing. All right, let's do the next one. The x-intercepts of the parabola are negative 12, 0, and negative 2, 0. Just going to draw a quick sketch over here. We have negative 2 and negative 12. This is our parabola that is really badly drawn. Then our axis of symmetry is the line in between them. So to get that equation, we're going to add those two numbers, negative 12 plus negative 2. And we're going to divide by 2 because we're averaging two numbers, so you got to divide by 2. Negative 12 plus negative 2 is negative 14. We're going to divide it by 2, gives us negative 7. Now your answer is not just negative 7, you have to write the equation x equals negative 7 because your axis of symmetry is a line, so you have to have the equation of the line. So it's x equals negative 7. All right, and last but not least, we have two symmetric points. So don't be thrown off too much, even though it's just two symmetric points and it's not x-intercepts, it's the same basic ideas. So let me graph it. You don't have to graph it, but I'm going to graph it. So we have negative 4 and 8. So let's just say it's up here. And 2, 8, it's up here. And I'm just going to draw it like that, whatever, it doesn't matter. It's just a sketch anyways. And halfway between that is right about there. Okay, so even though it's not your x-intercepts, it's going to still be halfway between because it's two symmetric points. So that means it's still going to be divided in the middle by the axis of symmetry. So the process is still the same. We're going to have x equals, take the x value and take the other x value, add it together, divide by 2. We're just finding the average of the x values. Even though these are not x-intercepts, you can still do the same process. So -4 plus 2. Remember, those are your x values, not the y. We're ignoring the 8s. Ignore those. So -4 plus 2 is -2. When you divide it by 2, it gives us -1. Remember, your answer is not just -1, it's the equation. Oh my gosh, I don't know how that happened. It's the equation x equals -1. Because we have a line here. So lines have equations. It's not just a number, it's the equation x equals -1. That is your axis of symmetry. I'm going to pause here and see if you guys need more time or if you have any questions. All right, so let's go on to part D. Determine the vertex of each parabola. So we are given the equation, and then we are also told the axis of symmetry for this first problem. So remember that the axis of symmetry always passes through our vertex. So if we know that the axis of symmetry is at this point, at the x equals -1, and we want to find the vertex, all we have to do is find out what is the y value when our x is -1. And to do that, all we have to do is plug it into our equation. So f of -1. So plugging it into our equation, instead of x squared, it's -1 squared. Instead of plus 2x, it's plus 2 times -1. And then we just have our -15. So we literally just plug in the axis of symmetry number into our equation. So when you're doing that, we're going to get 1 plus, or not plus, -1 squared is 1. 2 times -1 is -2. And then we have -15. So it's 1 minus 2 minus 15. That's going to be -1 minus 15, which is -16. So if we plug in 1 as our x value, we get that our y value is -16. So our vertex is -1 comma -16. I'm going to pause the video here, see if you have any questions. Now, all right, so number 3, it has x-intercepts 2, 0 and -6, 0. So they don't tell us our axis of symmetry, but we're going to first solve for our axis of symmetry and then plug that in. So we need our axis of symmetry. So I'm going to write axis, and then we have x equals, solve for our axis of symmetry just like we did in part C, in this section. So we have 2 plus -6 divided by 2. So solving for our axis, we get x equals 2 plus -6 is -4, and then we divide it by 2. So that means it gives us x equals -2. So this is our axis of symmetry. Now the problem becomes just like number 1. Now we can just plug in this -2 into our equation. So here's our equation. F of x is equal to x squared plus 4x minus 12. So I'm going to write f of -2 is equal to -2 squared plus 4 times -2 minus 12. I just plug in our axis of symmetry number, all right? So just plug in your axis of symmetry number just like we did earlier. And I know I'm running out of space, so I'm going to zoom in and kind of like section this off so it's not too messy. I'm sorry, they didn't give you very much space. You can use a scratch paper. So -2 squared is going to be positive 4 plus 4 times -2, that's going to be -8. And then it's minus 12 at the end. So 4 minus 8 minus 12, that's going to be, let's do 4 minus 8. That's -4 minus 12, which gives us -16. So -16 is the y value. And our x value was the x value of the axis of symmetry. In conclusion, we have -2, -16. This is your final answer. So the -2 that we got here, this is your axis of symmetry number. And the y value, this -16, we got after we plugged in our x value into the equation. Okay, I'm going to pause the video here, see if you guys have any questions. Let's do number 5. So I'm going to scroll a little bit. There we go. For number 5, we have that equation, 2 symmetric points on the parabola. So remember, when you have 2 symmetric points, we want to find the axis. So I'm just going to write axis of symmetry like that, just axis. X equals, we're going to add our two x values, -1 plus 9, and divide by 2. So -1 plus 9 is going to be 8. We're going to divide it by 2, which gives us 4. So our axis of symmetry is x equals 4. Now we're going to take this number and we're going to plug it into our equation. So I'm just going to use the bottom space because now we actually have space on the bottom. So plugging in the 4, f of 4 is equal to -4 squared plus 8 times 4 plus 20. Literally just following this equation, plugging in for any single time that you see the letter x. So x is 4, plug it in over here. And let's simplify. So we get -4 squared is 16. The negative stays out of it because the negative was outside of your parentheses. So we have -16 plus 32 plus 20. Then let's combine this some more. -16 plus 32, that's +16 plus 20. That's going to give us 36. All right, so our x value is 4. Our y value is 36. So where do we get the 4? It's literally just this one. Where do we get the 36? It's literally this number. I'm going to pause the video here, see if you guys have any questions. Let's zoom out. Oh my goodness, where did it go? All right, let me find it.
Miss Jade?
Yes?
I didn't get to finish number 5.
Okay, hold on. All right, so scrolling down to part E, we have to determine another point on each parabola. So we have, for number 1, the axis of symmetry is x equals 3. A point on the parabola is 1, 4. Okay, so I'm actually going to kind of sketch a picture. I think if you're a visual learner, it might help you to just sketch a picture so you kind of know what's going on for these types of problems. So that's why I'm going to sketch a picture. So for number 1, if we have an axis of symmetry at x equals 3, just going to draw a vertical line here, and a point on the parabola is 1, 4. So we have a point on the left side. If we want to just find a point on the right side, that's going to be the same distance from that point to your axis of symmetry, but just to the right side. So let me just draw a quick parabola through here. Remember that your vertex of your parabola is going to go through the axis. Okay, so let's see, what is the distance between this point, the -1, and your axis of symmetry? Oh, sorry, that's not a -1. That's a +1. What is the distance between your +1 and your +3? The distance between here. That's literally just 2, right? Like if you do 3 minus 1, that's going to give you 2. The distance between those 2 points is 2, right? Then you want to go to the other side and you want to go 2 more. So this should also be 2. So you should find a symmetrical point on this side. So to get that point, we're going to go from 3, from here, go 1, 2. So 3 plus 2 gives us 5. And how high should it be? It should have the same height as the original point. So if this original point was 1, 4, then this new point, we're only changing the x value here, it should be 5, 4. So it's the same height but it's symmetrical. So if the original point was 2 to the left, now we want 2 to the right. So now our new point is 5, 4. I'm going to pause here to see if you guys have any questions. So number 3 says the axis of symmetry is x equals 1. A point on the parabola is -3, 2. So I'm just going to draw another picture. Okay, axis of symmetry is 1, so here's 1. And a point on the parabola is -3, 2. So like somewhere over here. And I'm just going to draw my parabola. I know it's kind of big, but whatever. Okay, so just noticing that the parabola is going to have the vertex at the axis of symmetry. So now we need to figure out the distance between this point that they gave us and our axis of symmetry. The axis of symmetry was x equals 1, and this point was -3, 2. So to find the distance, we can subtract the two x values. So we have a 1 as the symmetry line and the -3. So when you subtract them, you can do the biggest number minus the smaller number. So where should I write that? Ah, okay, I'll write it over here. 1 minus -3, and that just means 1 plus 3, which means 4. So it's 4 boxes. You can also count the 4 boxes. So starting here, you go 1, 2, 3, 4. So this distance is 4. Some of you might have done -3 minus 1, which will give you -4, which is fine. You'll just know that the distance is 4. It's a +4 distance. All right, so we now know that one of the points is 4 to the left. We want to find 4 to the right now. So from our axis of symmetry, you go 1, 2, 3, 4 to the right, and then it will be this point. So let's see, 4 to the right. Yes?
Wouldn't the answer just be -2, 2?
No.
But didn't you say the way to like find the distance is like, what's it called? Like you would subtract the x with the like
Yes.
x. The,
yeah. So we do subtract them. So we have the x value of 1, and we have an x value of -3, right?
And then that would be -2, and then you said to not change like the other y value or whatever.
Okay, so if you look over here, 1 minus -3, when you subtract a negative, it's really adding a positive, so it's 1 plus 3. So that's going to be 4.
How?
It's like
because isn't it supposed to like cancel it out? You know what I mean? Like it's because like that's kind of how we learned it, right? Like if a positive goes to a negative, like you usually a negative and a positive like cancels out, so then you're only left with like -2.
I think you're thinking of -3 plus 1. -3 plus 1 is -2, yes.
Oh,
So
wait.
this is like if you have -$3, like you owe me $3, but then you
Oh, so if you're
pay me back
subtracting,
one.
you're basically adding the positive one and turning it like technically into a negative one.
Are you talking about this one?
Like if you were to do -3 minus 1, right, to get like -4 or something,
Uh-huh.
the subtraction would like take like basically make the one a -1, kind of.
Okay, this part just got covered by those other words. So you said -3 minus 1. This is a -4, right?
Yeah.
Yeah, so -3 minus 1 is a -4.
So the subtraction like makes the positive into a negative.
Subtraction. Yeah, like when you subtract 1, it gets more negative. Yeah, your answer becomes more negative.
Okay, thank you.
Okay. So then that makes the distance between this part, that makes that distance 4. So since we went 4 to the left, we also want to go 4 to the right. So then to figure out this second point over here, to go 4 to the right of 1, you're just going to go 1 plus 4, so that's 4 to the right. And once again, we keep the same y value. The original y value was 2. Sorry, I didn't mean to cross it out. 2. So we're going to keep the 2. So simplifying 1 plus 4, that's going to give us 5, 2. So this point is 5, 2. I'll pause here, see if you guys have any questions on this one. Okay, so I'm going to erase this bit just because I need space. I wrote too big for that last one. Okay, for number 5, the vertex is -1, 6. Here's my vertex. And a point on the parabola is 2, 3, so somewhere there. Okay, so this is my vertex. It's going to be shaped like that. Something like that, whatever. It's just a sketch. Anyways, so now we have our axis of symmetry that goes through here. Remember, your axis of symmetry always goes through your vertex. And so therefore, our axis of symmetry is x equals the x value of your vertex, -1. And then now that we've pointed out our axis of symmetry, we can proceed to solve this problem the same way we solved the other two, which is to find the distance between the point and the axis of symmetry. So our point is 2, 3. So to solve for the distance between 2, 3 and our axis of symmetry, we're going to take the x value, which is 2, and we're going to subtract the axis of symmetry number. So we have, I'll write it over here, 2 minus the -1. So 2 minus -1, and like we said, when you subtract the negative, this is going to be adding the positive, so it's really 2 plus 1, so you can get 3. You can also count it from here. You go 1, 2, 3. Okay, so the distance between those two is 3. So we know there's a point 3 to the right. So that 3 is like really hard to see. So we know there's a point 3 to the right, then we know there's going to be a point 3 to the left as well, because it's symmetrical. These parabolas are all symmetrical. So to find the point 3 to the left, we know the original, or the axis's x value is -1. So we're going to take the -1, and to go left, we're going to subtract 3. So earlier we went right, you add 4. This is going right, is adding. Now we're going left, subtracting. So we go start from the -1, the axis of symmetry. We're going left 3, so we subtract 3. And then you keep the same y value. Keep the y value of the other point. So it's -1 minus 3, 3. So simplifying that, -1 minus 3, like we said earlier, when you subtract a number, you're going to go more negative. So this is -4, 3. So -4, 3. I'm going to pause the video here, see if you guys have any questions. Actually, I think I probably should scroll up a little bit. Like that, maybe? So yeah, just to quickly point out, the y value of the point is always going to be the same. So if your point was 4, you keep your y value 4. If your y value is 2, you keep your y value at 2. If your y value is 3, you keep your y value at 3. The only thing that changes is the x value. So to find the x value, you just find the distance between the symmetry line and your point. So we can just subtract the vertex from the x value of the point. Yeah, that's exactly what we're doing. We're subtracting the two x values. Yes. So you subtract in number 1, you subtract 3 minus 1, and that gives you 2. And then you know that that's 2 to the left. So to get 2 to the right, you do 3 plus 2 to get 5 on the right side. And then on number 3, you do 1 minus -3. That gives you a distance of 4. And so that's 4 to the left side. then you want 4 to the right side, you go 1 plus 4, it gives you 5. And then for the number 5, you subtract -1 minus 2. That gives you a distance of 3, and we know that this is a 3 to the right, so when you want 3 to the left, you're going to do -1 minus 3, which will give you -4. Somebody says, so for example, in number 2, it says -4, you subtract it would be positive, so it's 4, 6. I think you should draw a picture so you know whether or not this point is on the left or right. If it's on the left side, you need to find the point on the right side. If it's on the right side, you need to find the point on the left. So on this one, if I were to draw it out, if I have an axis of symmetry at -4, and then the point on the parabola is 0, 6. So that means my graph's going to look something like this. Okay, so we are told this point, which is 0, 6, and we can find the distance between those 2 points by doing, yes?
Are we only doing through to letter E? Are we not gonna do F?
No, I'm trying to get there.
Oh, okay, my bad.
It's just that like, you know, with online school, it's really hard to like time it better, but we're trying to. We'll get there. F is really fast, and G is, maybe we can skip it. We can shorten G. Yeah, for number 2, this point is given on the right side, so you need to find the point on the left. Okay, so it would not be 4, 6. I'll just say that. How about it is up? Wait, I don't know what that means. So I really think if you draw a picture, it helps you see like where your axis of symmetry is. It helps you see where your point is. And then that way you'll know whether you're trying to find the point on the right or if you're trying to find the point on the left. And in the case of number 2, we're trying to find the point on the left side. Okay, and then let's do F. So this is determine the vertex of each quadratic function given in vertex form. Let's go back to our notes. Vertex form is box number 9. The vertex is going to be h comma k. So you're going to look for the opposite of what's in the parentheses. It's opposite because you see here it says x minus h. So that just means you're going to find the opposite. So the opposite symbol, so if it's positive, switch negative. If it's negative, switch to positive. So h is opposite and k is going to be like exactly as it appears. So if it says +2, then it's going to be +2. Okay? So h is opposite, k is exactly as it is. Let's go to our skills practice and please load. Okay, thank goodness it loaded. So here we're going to take this -3. It's going to be +3. We're going to take the +8, +8. So it's the opposite of what's in the parentheses. And then this one is just as is. Okay? So our vertex is 3, 8. For number 3, it's the opposite of what's in the parentheses, and it is as is for the number outside. So the opposite of -1 is +1. And then we take the outside as is, so it says -8, then it's -8. So our vertex for number 3 is 1, -8. And then finally for number 5, we have opposite here, and then as is for outside. So if it says +9, and we want the opposite of that, we're going to want -9. And then for the -1 on the outside, we're going to take it as is, so it's -1. See, I told you section F was really fast. Any questions about section F? Oh, okay. I'm going to shorten section G. It says identify the form of each quadratic function as either standard form, factor form, or vertex form. I'm just going to have us do this part. we're not going to state all we know about the quadratic function's key characteristics based on only the given equation because there's not enough time right now. So we'll get to it another time if necessary. So we're going to identify the form of each quadratic function as standard form, which looks like this. Or it could be factored form, which looks like this. Or it could be vertex form, which looks like this. Okay, so I guess the way I would look at it is if it has a lot of parentheses, then it would be factored form. Okay, so notice that there's 2 parentheses pieces. That will tell me it's in factored form. If you see the parentheses being squared, that will tell me it's in vertex form. And then if you don't see any parentheses at all, then it's in standard form. That's how I would look at it. So for number 1, when you look at it, I see a parentheses being squared. So which form would this be in? You guys can just shout it out.
Vertex.
Vertex, good. All right, number 3, I see no parentheses at all. What form would that be?
Standard.
Yes. Thank you. And then the last one, I see something being squared in the parentheses.
Vertex.
Vertex, good. And then I guess because we didn't get an example of it, I see this one, I see 2 parentheses. What would that be?
Factored.
Yeah. I know that was an even number, but you guys can do 4 and 6 on your own. Somebody asked, how would we do number 6? Oh, okay, so I think your question was about this number 6, correct? We had a question here in direct messages. How would we determine the vertex of this one? That's a good question. So if I see nothing on the outside over here, that just means it says +0. So remember, we want the opposite of what's inside the parentheses. So that would be +5 because it says -5. And then we're going to take this one as is. So if it says +0, I mean, it really said nothing. But if it says nothing, we know we're adding nothing. So that's adding 0. Then that means we're just going to have 5, 0. Very good question. Thank you for asking. So we just did number 6 of part F together as well. Are there any other questions that encompass F and G? We finished in time. That was really good. I'll pause the video so you guys have time to ask. And I'll scroll up because I think some of you might not be able to see number 5 if I haven't scrolled down so much. Okay, I don't know if you guys have questions, but I didn't hear any, so I'm going to stop the recording.